Alright, we got the cone gravel question in there. That's the one we're doing. Alright, so the cone gravel question is number 27 on the 3.9 textbook. It's not the same question because these are different numbers. Like I said, don't just copy the answer. You have to remember how to do it. Or, like, at least memorize the steps. But, basically, it's this one. I don't know why I said basically. Yeah, it's this question. So, gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute, and its coarseness is such that it forms a pile in a shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? So, we have a cone, and gravel is being dumped on the ground, and it's making a cone. So basically, the volume's constantly increasing because the cone's getting bigger. And, volume is the amount of space something takes up. So if you're adding gravel to it, then it's gonna take up more space. So that means that the volume's increasing, which it says it's being dumped at a rate of 30 cubic feet per minute. So we know that the rate at which the volume is increasing, or dV over dt, is 30 cubic feet per minute. My handwriting was kind of awful there, but oh well. God, alright. So, now we need to know the formula for the volume of a cone. So, the volume of a cone, I'm pretty sure, is V equals pi r squared times the height of the cone divided by 3. And let me make sure that's actually true. It is. Look at that. Look at us go. We know cone formula. Yeah, that's important to know. Not like they give it to you on the AP exam and it's perfectly fine not knowing it. Okay. So we have this, and we have this. We have the volume formula, and we have the rate at which the volume is increasing. Now, the question is asking how fast is the height of the pile increasing when the pile is 10 feet high. So, it wants the rate at which the cone's height is increasing. So, that would be dH, over dt. Then this is going to be how fast the cone's height is increasing relative to time. So we're solving for this when it's 10 feet high. So when h equals 10. So another thing is we can't do this yet because we have the r, we have the h here. That's two variables. So let's see what other information it gives us. Gravel is being dumped on a conveyor belt, in a cone whose base diameter and height are always equal. So the diameter is always equal to the height. So what do we know about diameter? Well, diameter is double the radius. So capital D equals 2r, which means that r equals d divided by 2. Okay, that is a p, but whatever. D divided by 2. And because diameter d is equal to height h, we know that r is equal to h over 2. Because it says that the diameter and height are always equal. So you can just replace diameter with height, and you can replace this r squared with, we got v equals pi h over 2 squared. And then I'm gonna make this 1/3 h, just so it's easier to look at. I don't know, it's easier for me to look at it like this. And I'm going to do one more thing before we start taking derivatives and stuff. I'm gonna make it so that it's easier to actually do that with this. So you have, I'm going to apply this squared to the h over 2. So you're basically multiplying 1/2 h times 1/2 h. So basically it's going to be v equals pi times 1/4 h squared, because this is basically going to become h squared over 4, so that's 1/4 h squared, times 1/3 h. So now, one more thing, v equals basically 1/12, because you multiply the 1/4 and the 1/3 and you get 1/12 times pi times h cubed, because you multiply the two h's and you get h cubed. So now, well, all we have to do is we have to find dh over dt. So what we're going to do is we have to find the derivative of this relative to time. So basically we change v into dv over dt and make it, and then that equals, we have to find the derivative of this, so it's with h, so basically just take the 3 and multiply it. So this is going to become 3/12 pi h squared, and that's going to be 1/4 obviously, but we'll get there in a second. Well, we could get there now, it doesn't matter, but you know, h squared, and then we add dh over dt, because remember, because there's no time variable in here, and we're taking the derivative relative to time, so when we do that, we have to add the dh over dt at the end. We have to multiply our normal derivative by dh over dt. And that basically allows us to set up an equation with time involved, with, you know, because time's not actually involved. Okay, so now we just plug in what we have. So we know that dv over dt is 30. Okay, focus, thank you. Oh, okay. Why is it focusing on my hand, man? Alright, 30 equals 1/4 pi, and then h squared. We know h is 10, so 10 squared times dh over dt. Oh my god, my handwriting. No, hang on. Okay. Alright, times dh over dt. It magically fixed itself. Okay. And so now we just get dh over dt by itself. So 10 squared is 100, and then divided by 4 is 25, so this is 25 pi. So 30 equals 25 pi times dh over dt, and then basically dh over dt equals 30 divided by 25 pi, and we can simplify this because 30 and 25 are both divisible by 5, so that's going to be 6 over 5 pi, and that is going to be, oh wait, you have to put the units, I'm foolish. So it's, the units are, let's see, it's the rate at which the height is increasing, and it's going to be in feet. It's in feet per minute. Okay, the unit is feet per minute, and it's just going to be regular feet per minute, because it's not area and it's not volume, so it's just going to be regular. Okay. Once again, that's the second of, I think, like 4 or 5 of the word problems that are on the test. I'm going to be doing all of them. Remember, if there's something that you're still confused about, remember this is number 27 on the in the textbook, and this is the correct answer. I checked it right here, 6 over 5 pi, or that, but we hate that, so we don't talk about it. Remember, if this is still confusing to you, if you still want if you want a better explanation of it, or if there's just something I could clear up for you, don't hesitate to let me know, and I will try to help. We got a test we gotta get a 10 million% on, so may as well abuse the fact that we know what the word problems are now. Alright, that's this, and I will move on to the third one after this uploads, because I don't have space on my phone. Okay, bye.